I'm back at the bench, which means another electronics project. Ooh. Busily waiting to get on with the station. I absolutely haven't forgotten about it. Waiting for some bits and pieces to come for the underside of the canopy. And once they arrive, we'll get back on with that. I hope you enjoyed taking a look at the 1962 stock underground train the other day. It's what got me thinking about this project. Come on, let me show you. This is what made me think. Do you see that? This end of the train and that end of the train operate as two completely separate trains. The join here, there is no electrical connection whatsoever. The motor for this part is right here, and the motor for the other part is all the way at the other end. Now then, let's, instead of fooling around with a lovely new train, let's simulate this on the bench and you'll see what the problem is. So here's our setup. We've got a locomotive pulling a carriage, a train, the gentleman on the platform waiting for the train. He's about to get on. And here's the clue. Do you remember our diode across the gap? Let me just push the train out of the way so you can see that. There's the gap in the track. There's the diode. Now then, we built a little circuit a few videos ago. When the polarity changes, the locomotive will take off. You missed your train. And all I'm doing at this end is reversing the polarity by turning the battery one way or the other. So if I make the train go backwards into the station, it will stop in the same place every time. Stops right there. There he is, about to get into the train again. Too slow. And when it comes back, exactly the same space every time. That's because that wheel has just gone over that gap. Bog standard DC shuttle system. Now, I noticed the problem with this with DCC. We're not going to get into that tonight. Just a simple DC shuttle. Now, let's say the train comes in the other way round. There we are. So there's the train. Now, all I'm going to do is pick it up and turn it around the other way. The scene is set. There's our friend waiting for his train way down the track. Here's our locomotive pulling its train, and it's about to come into the station. Well, it's stopped in exactly the same space, but look now. The train is way up the line, and he's going to fall on the track. Now let me simulate the underground train. The underground train is 4 cars long. You have a driving car, a trailer, and a driving car. In our desktop simulation, we need 4 cars, not just 2. Enter Connie and carriage, and I will show you what I mean. Now I've had to add a section of track, so things have moved a little bit, but we still have our break in the rail with the diode across it. We still have our platform, and somebody is still waiting for the train. So how's this going to work? There's our train. Connie, trailer, and test locomotive with firebox flicker. And if you don't know what I'm talking about, you can check out that video. Alrighty, so now we've got an even bigger problem. Let me just power it up and I'll show you. So as I put power to the track, both trains take off. Our test locomotive has gone over the gap and stopped. And Connie, struggling for all she's worth to get the train to move. Let's take the battery off. This isn't good, is it? If I remove the test locomotive, Now we can make Connie go back into the station. There she goes. And now our passenger can get into at least one of the cars. And when I reverse the polarity, off we go again. So what can we do about this? So we've got two problems. One, when you've got two locomotives on the train and one of them goes past the gap, and the other is when the locomotive comes in backwards. So in other words, when this one comes in, the carriages are going to wind up at the platform, or at least one of them is. But if you turn it around, the locomotive is going to stop there with the carriages sticking out here. So tonight's project, I'm going to try and come up with something that would solve that. Mostly, electronics is about stringing together simple principles and adding to them. So we've already talked about a shuttle circuit that simply does what I've been doing with the battery, reversing the polarity. The diode across the gap simply stops the train once it passes it. But it does something else too. I am going to shorten our train down to 3 units, but the same principle applies because our test locomotive has run out of track. Now then, let me show you something here. All I'm doing here is applying volts to the rails. One locomotive, Connie, is going to be right at the gap and will cross the gap. But as Connie goes across the gap, her wheels will provide power to the test locomotive by short-circuiting momentarily our gap. Let me show you. So even though our test locomotive is way beyond the gap, when I add power to the rails, did you see the wheels turn there? Now both locomotives are past the gap now, so neither one will work. I've still got the power on. If I turn it the other way, they will both run because the polarity of the diode allows current to flow. So now they'll both move, and there we go. And it was that made me a little cross when Bachmann didn't join electricity from car 2 to car 3, because you now can't run the underground stock on a standard shuttle. So anyway, that aside, we'll solve it. On my drive home, I was having a little think about how I would solve this. And with electronics, what I like to do is break it down into bite-sized chunks. What I think we need to do is simply join our gap back up again. So we short out the diode until the train has actually passed the gap, all of the train. So we've joined the wires together so that even when we're all the way up here and the rails are not being joined together by Connie's wheels, we'll short circuit the diode so that our test locomotive still has power until the whole train gets to there. So it's just a little bit beyond the gap, and then we'll break the short circuit. So how do we come up with something that is going to do that? And so the front of the train always, or the back of the train always ends up there, which means that Mr. Jones, or Die the Steam, was it, in Ivor the Engine? I do like that they're bringing that model out. That would be interesting. Ivor the Engine. He's always going to line up with the carriage. So how do we do that? Let's have a little rummage. We're going to need some of this. We're going to need the jumpers. Now, I was looking everywhere for those the other day, and there they are. I shall remember where they are now. could use reed switches, but I'm not going to. That would require modifying the train in some way by adding a magnet. That's stuck nicely to the bottom of the drawer, by the way. That's the other box of reed switches with the magnets there. I still haven't really got myself sorted out. I am hunting here. These are popping out of the packet again. We don't need that. A 9-volt relay. I think we need one of those. I wonder if there's one on the project boards. Not in there, in here. There is one there. That's a big old mess, isn't it? Not using that. So a 9-volt relay. I'll take the packet and bring it back. There we go. Gonna need a transistor. I'll take the box, and I think this is what I'm looking for. Yes. I dropped the box. Oops. Well, that was annoying. Oh well, I think I only need one of them. Now, what else do I need? Well, my bits and bobs box. All I'm looking for is a diode. There's bound to be one in here somewhere. I can see a couple of them. There's a transistor in there too. I needn't have been digging around in the new box. There we go, a diode. So my reusable parts box. Every now and again go through the box and put stuff back where it really lives, but it's a nice place to throw things. So what we have then, variable resistors, jumps, breadboard, diode, relay, soldering iron is on, a few crocodile clips, and I think we'll be fine. Oh yes, the major component in here are variable light dependent. I'm struggling opening this with one hand. If you drop this one, it wouldn't open. There we go. Light dependent resistors. Just need one. Come on. Right, let's come up with a circuit. Now again, the components I'm using are simply the ones I have available. They might or might not be the right thing, but I'm sure we can get something to work. So this is a light dependent resistor. Can you see what it looks like? It's got that zigzaggy look in there. You see that? I think with just those components we can make this happen. The diode. What's the diode for? Let me draw the circuit and we'll show you. The diode though, that's whenever you're using a relay, because of the coil in it, when the coil lets go, we get what's called a back EMF, and so the coil generates relatively high voltages, and so the diode simply goes across that to short it out. I've covered that in depth elsewhere, but let me draw a little circuit for us. 9 volts, simply because we got a 9-volt battery. So we'll have a plus rail and a minus rail. So this one's plus. And in between them, what do we want to do? Well, we want a relay. And we'll draw the relay like that. And like that. So when the relay is energized, it joins that together. So this contact and that contact go out to the gap in the rails. So that's where they go. From also across this relay, we need a diode. Don't forget it. And that goes in there. That goes into, I always leave myself not enough space. Look at me, cramming things in now. We need a transistor. And we use an NPN transistor because I've got a box of them that were all over the floor. And a potential divider. So a resistor. and another resistor, and we'll make this one variable like that. Should be a little arrow on that, and joins to there. And this one is the light dependent, so the arrows are coming in. It doesn't give off light. If it does, you've done something really wrong. So how does this circuit work? Light falls on the resistor, the resistance changes the voltage there. So if you've got 9 volts across here, let's just put a number on this of 700 or whatever, and that's 700. Then the volts in the middle would be 4.5. If the light shines on it, the resistance goes down, so that volt there would drop. If the light goes away, it goes up. So either way, this thing, the transistor is going to do something, because now it's either getting volts or not getting volts, and this relay will either go clunk or not clunk. The sensitivity of the thing, the midpoint in other words, will be adjusted by that resistor. I'm hoping. We shall see. We could put the relay in the emitter leg. That would be a more surefire way of making sure this thing works, but let's give it a go and see what happens. I'll tidy that up and you'll never see it again. Did it come through? It did. I was going to do it on the other side. Never mind. I did put the card down in case my Sharpie went all the way through all over the nice workbench. Let's put this on a breadboard. I really have oversimplified this. I'm just having a little think now. I'm wondering, should I put a resistor in series with that? Depends on the characteristics of this transistor, because the relay coil will look a bit like a short circuit to DC. Well, we'll give it a try, and if it smokes, we'll find another one. Does it reach? It does, sort of. That was easy, wasn't it? You could probably make the diode fit around the... Can I? Yeah. So that's the diode. That's cheating, but it worked. These jumpers are cheap and nasty. I prefer thicker wires than these. I'm reaching for a pair of tweezers. There's one in the box, Ian. Yeah, I know, but they're not. There we go, a couple of those. Now, if I dropped that box on the floor, I wouldn't be happy. I'm already covered in dog hair where Shadow's been shedding. So from the plus to there. So now we're going plus to, where's my circuit? Reinventing it. So I've got this connection, that connection, the relay. I need to now get a transistor in. And you go. Make sure we get that the right way around. I'll draw that for you. So the D of the transistor has 3 wires coming out the bottom. The middle one is the base, the bottom one here is the emitter, and that's the collector. That's C, B, E. So I've got the collector joined to that. Now the emitter, where's my other jumper. I got another one out, I know I did. I repeatedly forget that there are always new viewers. So really quickly, this is just a tiny piece of what's called breadboard. And all of these holes are joined together, as are all of those in one long line. These are the plus and minus rails. On some really better boards, the plus here is joined to the plus over there. That isn't the case on this, I don't believe. Then in the middle here, these rows or columns or whatever, all of those are joined together, all of those are joined together, and so on all the way down. So now up here, the plus goes to there, and plugged into there is a diode, and the one side of the relay, and the diode goes across the relay. The other side of the relay is joined to these. There's a gap in the middle here, you see. So that goes to the collector, and only the collector, just like that. And then the emitter goes to there, and I've jumped it across to the minus, and I'll hook up a battery from minus to plus at some point. Not just yet. Now, where's my variable resistor? There it is. These are always a little awkward on these boards. And I really don't think there's a good way of doing this. So what we usually end up doing is jamming them in across the board. So I'm just going to solder a couple of wires to the end of there, or join them in some other fashion. Now that some other fashion is this. Looks like a bowl of spaghetti, because I would sooner solder wires on than use it. But since it's you, I'll do it. The way these things work, if I can untangle one. So there's a clip on one end, and I always refrain from saying crocodile or alligator, because somebody will always tell me it's the other. And on the other end is a pin, and that pin jams into the board. I do need to just move the base away from there, and moving things away is a good thing to do too. Am I in the right place? I am. And just shove this off over there somewhere. So now I've got a bit of extra space. That's this point here. And I need a variable resistor, so I'm going to jump that clip in there. And somewhere under my spaghetti is a variable resistor. There it is. And I can join one of the legs like so. Let's put the cover on so that it doesn't join up with everything else in sight. Have I broken them all? No, here's one. So we're going to bring it back to the positive rail. Do you see there? So we'll just shove that into the positive like that, and we'll join this clip up to the other two legs. You're not following this, I'm quite sure. Two legs at once. Can I do that? I'm taking chances here. Cover it up. That looks about right. So the crocodile clip, I did it, joins two of them together, and the third one goes there. The crocodile clip is making that connection because it's the yellow one, and the blue one's making that connection. Now we need the light dependent resistor. I really would like to put that out on a leg too, but for now what I'll do is I'll poke it in the breadboard right here. See, there it is on the circuit diagram. That's the negative rail, and we need that rail there, so it's going from there to there. In you go. There we are. It's in the circuit. Now clearly we're going to struggle to get this near a train, but that's the concept then is as the train comes along, it's going to cast a shadow over that resistor. You see that? Shadow, shadow. We'll see what that does. I think that's it. It would be a whole lot less complicated if I shortened the wires, but nevertheless, I think we're there. Now all I've got to do is join a battery to plus and minus. Now let me quick check this. Plus from the battery, minus from the battery, relay. The plus runs to the relay through a diode, which is pointing the right way, to the collector, yes. The base runs over to the potential divider. One side goes there, the other side goes to the LDR, light dependent resistor, which is hanging off the end there. The emitter, collector base emitter is joined to negative. So yes, so if I hook up a battery, we'll see what happens. It's working. So I don't know if you could hear, but when the shadow goes over the light, listen carefully. So the circuit's working. Now we've got to hook it up. So I just need to hook up a couple of connections to the diode there. This is the diode across the track, the gap in the track. The question now is, what do we want it to do? What we want is when the relay is activated, when there is a shadow over the light dependent resistor, we want the contacts that join together then to be activated. So the middle one, now I can't see where they are, so I'm going to cheat here and find another one. So it'll be that row there. There we go. So those two wires go off to the track. I'll show you. There you are. They're just either side of that diode that's across the gap. Look, that's handy, isn't it? The arches hold the card. I said I'd redraw it. 1N4001, or any diode basically, that can take about 40-50 volts, which is probably what that's going to generate. I've used a 200 kilo ohm resistor, variable resistor. I haven't touched it. It's roughly in the middle, so yeah, do the math. The transistor I am using is a 2N3904. It is ill-designed for the relay that it's driving, but that's what I've got. Well, all over the floor too. A variable resistor. We'll have a look at that in a minute and see what the resistance range is. I'll pull out the meter, but let's get this thing working first. We're working backwards. There's the light dependent resistor beside the track, just looking at a light across the street there. This could be your room lights. You just have to arrange this thing so it's pointing at a light that the train is going to get in the way of. And then I will hope, we may have to do some adjustments. I haven't tried it yet. So there comes the train out of the circuit, and we'll just send it back in, see what happens. It worked, but it worked too soon. I need to reposition the light dependent resistor. We've moved the track, of course. So now there's our gap. Let's move the light a little bit down the road. So I'm over exaggerating the light and all of that good stuff, but to make the point, let's see if this works. We'll drive the train out. There it goes. Oops. You do have to take the battery off the track here, and otherwise it will crash into your hand. And now we'll send it back again. Right now what's happening, a big bright light shining across the track. By adjusting the resistor, that would be more or less sensitive. Let's send the train back and see what happens. Well, it stopped beyond the gap. Do you see that? And it kept going. And now Mr. Jones is lined up with his carriage. I'll bring it out again. And this time when it comes in, I want you to see that the wheels on the test locomotive are still rotating all the way in. And we can adjust only when the light then shines on the light dependent resistor. Does that relay open back up again? Isn't that fun? So now with this little circuit, and it really is a simple circuit, isn't it? We could run the underground train on DC on a shuttle circuit, and the only addition to an existing shuttle are two connections, one either side of the diode, or if you prefer, one rail and the other rail. That's all you're doing, just short-circuiting the gap. And what happens then is that the relay will stop the train once light hits the LDR. So here's the thing, we could take the locomotive off and add a second carriage. Look how close we are to the end of the track, but does it work? Let's have a look and see. So pulling the train out, here it comes. And when it comes back into the station, it stops with both carriages at the station. Now, if I were to put the locomotive on the other end of the train, what would happen? Let's try and see. Here it comes. Now, when it comes back, what happens? Do you see that? Okay, so the platform's only long enough for one of the carriages, but the train went back and stopped in the same place. Yes, success. Nice little project. I hadn't thought about doing this until this time. The advantages of it, well, I don't care that we're using the wrong bits. It's working. But the advantages are that any length train with a locomotive at either end or two locomotives will pass the join and go to wherever we set up the shadow. I think that's rather lovely. I'm not stalling on building the station. I just don't have what I want. A number of things that people have suggested have been very helpful. I think my favorite is getting, this is U-channel brass, getting some U-channel styrene for the lights that are going to run down underneath the canopy. There's a last look at the rather messy but hand-drawn circuit diagram for you. You can stop and freeze for that if you want to. And that's it for another one. Thanks so much for watching. Please hit that like and subscribe and let me know what you want me to do. You've seen me do this particular circuit in real time with no trickery. If there's been problems, including dropping 200 transistors on the floor, I'll show you the faults and all. Thanks for watching. See you next time.